Hi everybody, we are going to solve paper 4 version 2 February-March 2019. First question, define acceleration. It is rate of change of velocity. This time graph for journey of a cyclist. Describe motion of cyclist in time between 0 and 15 seconds. As we see, the slope increases, so velocity increases. 15 and 30, it's a straight line with a constant slope, so velocity constant. 30 to 40, slope begins to decrease, so velocity decreases. Average speed is total distance cut in the 40-second journey as a whole, and which is 300 meter, and in time 40 seconds, so average speed will be this total distance over time taken to cut this total distance. Maximum speed, as we saw in the first portion, slope increases until it reaches this constant slope and then decreases, so this will be the maximum, and to find it we should find the 2 points on the graph. Let us choose, for instance, the points 250 with 30 and 100 with 15, 16, 17 and 17.5. As from 20 to 50 there are 5 small squares, so every square is represent 1, so this value will be 17.5, and the slope will be 250 minus 100 over 30 minus 17.5. This will equal state 1 advantage and disadvantage of using wind turbine, a source of electrical energy. Advantage, it is renewable, and the disadvantage, it is seasonal. Wind blows at speed 60 meters per second towards turbine blades in 1 second. A volume of 24,000 meter cube of air passes through circular area swept out by blades. Density of air is 1.3 kilogram per meter cube. Calculate mass of air that passes through circular area and swept out by blades in 1 second. As in 1 second there is a volume of 24,000 meter cube, and we have the density of the air, so we can simply calculate the mass by the relation rho equals m over v, so m will be equal 1.3 times 24,000, so it equal kinetic energy of mass of air that passes through area swept out by blades. It will be given by the relation half mv squared, so it is half times m that we have just calculated times v, which is 16 meter per second squared. The answer will be, suggest why some kinetic energy of air that passes through blades is not converted into electrical energy. I will say that because it is lost in overcoming friction of blades around the axis of turbine. An object is moving in a straight line at constant speed. These three ways in which force may change motion of object. It can increase the velocity or decrease the velocity, which is accelerate or decelerate the object, and it can change direction, which is the circular motion. Object suspended from two ropes. Weight of object is 360 Newton. Magnitude of tension each rope is T. And the space below determines the T by drawing the vector diagram of forces. State the scale you have used. I will choose 100 Newton to be represented by 1 centimeter, so 360 Newton can be represented by 3.6 centimeter, and I will draw the vector diagram like this. An arrow with 3.6 centimeter length and another arrow to represent T. Its length will be known by using the ruler, and then I will close the triangle by this vector. Okay, to find the value of T, I will use these values that I have measured with the rule and multiply it by 100 to give the result in Newton. Barometer is not in new syllabus. Set values of fixed point of temperature scale. It is 0 degrees Celsius for freezing point and 100 degrees Celsius for boiling point. Graduation on liquid and gas thermometer are equally spaced. For equal spacing of graduations to be correct, state an assumption that is made about the liquid in the thermometer. Okay, liquid should have uniform expansion or linear thermal expansion. Okay, so it increase in volume with same value for each 1 degree Celsius increase in temperature. An assumption that is made about structure of thermometer. Its cross-sectional area should be constant. So the volume increase due to heat increase or temperature increase is noticed as an increase in height. Okay, so cross-section should be the same along the wall liquid and gas thermometer, and volume is A times H, so an increase in volume means an increase in H, only in H. Thermometer A has greater range than B. State one way design of A is different from B. As A has greater range, we expect it to be taller than B. C, greater sensitivity than D. One way C is different from D, it will that C liquid has greater linear thermal expansion than D. In space provided, draw a label diagram of thermocouple thermometer. This consists of two metal wire, different metal wire from metal A, and this is metal A also, and metal B, okay, welded at both ends, and one end is in hot and the other in cold. And certainly the avometer or galvanometer or ammeter will deflect as there is a difference between the temperature of both ends. Suggests when a thermocouple is more suitable than liquid in glass, when greater range is required, and when faster response is required. Electrical heater placed on floor of room. Heater is switched on. State main process by which thermal energy is transferred to air in all part of room. Certainly the convection. Heater has power of 1.5 kilowatts. Air has mass of 65 kilograms. Specific heat is 720 joule per kilogram Celsius. Calculate time for heater to raise temperature of air from 8 to 15. So we know that heat is equal to mc delta T. M of air in room is 65, C is 720, delta T is 7. So total energy needed to heat the room will be 33 for zeros joule, and the power as it equals to E over T. So time to get this energy from the heater will be Q over V, which is two reasons why time calculated in BIs smaller than actual time taken to raise temperature of air in room because of heat loss to surroundings like furniture and heat loss to incoming air from window. Small circles represent molecules are referred to change in state. Change of X is from certainly solid to liquid, and change of Y is from liquid to gas. Explain in terms of forces between molecule. Why gases expand more than solid when they undergo same rise in temperature? Because intermolecular forces in solid is greater than in gases, and intermolecular spacing is in gas is larger than in solid. Cylinder of volume 0.012 meter cube contains compressed gas at pressure 1.8 times 10 to 6 Pascal. Valve is opened and all compressed gas escapes from cylinder into atmosphere. Temperature of gas doesn't change. This statement indicates to use Boyle's law, which relates to change in pressure and volume at constant temperature. Calculate volume that the escaped gas occupies at atmospheric pressure. Okay, if all the gas contained under this pressure goes out to the atmospheric pressure, the change in volume will be V2. So V1 times V1 will equal V2 times V2. The answer will be 0.216 meter cube or 0.22 meter cube. But this is the volume if all V1 goes to the second container and there is no more gas in the first container. But this is not the case. Although most of gas escape to the less pressure, there exists gas here in the first container that has the volume of the container, which is 0.012 meter cube. So the escaped gas would be the difference between the case if all of the gas escape minus the little amount that occupy the same volume. So it will equal to 1 meter cube. Barrel wavefront of light, wave and ice. Wavefront are incident on boundary with air. Speed of light is 3 times 10 to the power 8 meter per second. Refractive index of ice 1.3. Draw wave fronts of the wave that passes into air. We know that direction of wave is perpendicular to the wave front. So if we draw a ray or an arrow to represent this direction, which is parallel to it, we expect that transfer of light from ice to air makes the ray deflect away from normal. So it has change in direction that makes the refraction angle greater than the incidence angle. Okay, so to draw the wavefronts of light in air, it should be in a way that a direction parallel to the reflected arrow that we just draw must be perpendicular to the wavefront that we intend to draw. So we can make something like this. They should be parallel, of course, and have same spacing. If we extend each of them greater length, so we can have a ray that is perpendicular to each of them and parallel to the refracted ray. Okay, draw arrows to show direction of travel of refracted wave. Okay, label angle of incidence and angle of refraction. Okay, calculate speed of light wave in ice. We know that n is equal to c, speed of light in air or vacuum, over speed of light in medium. So the speed of light in ice would be c over n, which is 2.3 times 10 to 8 meter per second. Current and potential difference graph for resistor and thermometer. Calculate resistance of thermometer when potential difference is 7 volt. 7 volt, so we will get here, and the value of current will be 4, and here is 5 small squares to reach 5, so each small square represents 0.2 ampere, so this is 4 plus 1, 2, 3, 4 plus 3 times 0.2 ampere, which is 4.6 ampere. So this value is 4.6, value of current when potential difference is 7. So if we want resistance, we know from Ohm's law that V equals I times R, and R will be over I, which is 4.6. This will equal 1.5 ohm, and don't forget the unit. In the table, resistance increases as we go from 0 to 7 volt. With respect to the resistor, we should notice that slope of this graph is the inverse of resistance, because as we just said, Ohm's law is V equals IR, and the relation drawn here has I on the y-axis, okay, and V on the x-axis. So we should have a slope of 1 over R, okay. Just we divide this side by R, and we get the relation that is drawn. So the slope of this graph represents the inverse of resistance, and as resistance increase, as potential difference increase from 0 to 7, we have for the resistor that it is a straight line, so the slope is constant and the inverse of resistance is constant, so the resistance itself is constant. This is for resistor. Okay, so it will not be increase or decrease, it will be constant. For the thermistor, we have an increase in the slope. An increase in the slope means 1 over r increases, so r decreases. This is for thermos. So as we go from 0 to 7, we have resistance decreases for thermos. Thermistor and resistor are connected in parallel to 7 volt. Calculate current from supply. Again, using Ohm's law, V equals IR, we saw that how both resistor and thermistor at 7 volt potential difference has the same value of current, which is 4.6 ampere. So we will imagine the circuit to be like this. This is the resistor and it is connected in parallel to the thermistor. So current here and current here is 4.6, 4.6 because they are in parallel. So the total current from the supply will be the sum of both of them, which equals. So as we calculated the power of the supply using total current drawn from the supply that we calculated from CI 9.2 times 7, which is the voltage of the supply, we got 64.4 watt. This is the total power of the supply. Okay, but the question asks about energy transferred from the supply in 5 minutes. So as we know that power is equal to energy over time, so energy is equal to power 64.4 times time. Time here is 5, but this is 5 minutes, so we should convert it to second because this is in watt. The answer will be 19,000 joule. Electrical energy produced by power station is transmitted over large distance at very high voltage. Explain why a very high voltage is used. Because we know that power is equal to I times V, so we can either transmit power with high I or high V. If high I, power loss will increase because power loss equals I squared times R. So we choose the high voltage. And if we choose I to below cables will be thinner and hence cost effective. Here is a transformer, primary coil 4000 turns and 120 volt, and secondary coil 9 volt. We will certainly ask about number of turns in secondary coil. we have the relation that ns over nb equals vs over vb. So number of turns in secondary coil will equal vs, which is 9 over v 120 times mb, which is 4,000. This will give us 300 turns. State suitable material for core of iron transform. It is soft iron, and for coils it is copper. Isotope of iridium 194 decays by beta emission to platinum. Complete nuclide equation. We know that in beta decay, neutron is transferred to a proton and beta particle. So mass number remains the same, atomic number increased by 1, and for beta particle mass is so small, almost 0, and the atomic number is -1 as it represents a decrease. Half-life of iridium is 19 hours. Sample of iridium has initial count rate of 1100 count per minute. Calculate count rate after 38 hours. For the first 19 hours, this count rate will be reduced to half of it, so it will be 550. And for the second 19 hour, 550 will be reduced to the half, so it will be 275. Okay, count per minute. State two ways in which gamma emission differs from beta emission. It is an electromagnetic radiation, and beta is electrons. It has low penetration, and V has medium penetration. Sorry, has high penetration, and beta has medium penetration, and certainly alpha has a low penetration. Thank you all.